and that is will be given by Puteri of Bandira about optimal solar flight site selection in using GIS multi-career decision making and NASA power data. So also speakers, I will be controlling the slides, so just let me know that if you need me to advance the slide, just say next slide and I will advance the slide for you.
Okay, hi. Can you hear me?
Yes, we can hear you.
Okay, thank you so much. Okay. Assalamualaikum and good evening from Malaysia. Thank you to the NASA Power team for the opportunities given to me today. I am Puteri Bandira, representing an organization called the Geoinformatic Units in School of Humanities, University Science Malaysia. So the topic I am sharing today is climate change and sustainability agenda, as our works that uses the NASA Power data revolves around the field of climate change and sustainability agenda. So this unit was established back in 2001, where we uses GIS to conduct research, teaching, and consultation services to improve the understanding of the human environment interface and the sustainability agenda. Okay, next. Okay, so we have been using the power data products starting only last year, 2022. Hence, we have a limited work done using the product to showcase tonight. But overall, as our main analysis revolves around the use of GIS, therefore, to conduct GIS analysis, we require a high quality meteorological data that covers the entire study area. However, the problem with a developing country like Malaysia, the ground measured data collected is located far from each other, resulting in a sparse meteorological data characteristics. So if you can see from the map, the dot and triangle represents the location of meteorological stations in our study area, and obviously it does not cover the entire study area. So our common practice would be to interpolate the ground measured data, realizing that we are jeopardizing the accuracy of the analysis. Thankfully, now we have another options where we manage to demonstrate a good performance of the power data products in estimating local scale meteorological conditions. Hence, we use the data as our climate input for our GIS model and come up with a solar farm site selection map. Next. This is the the suitability map for our solar farm installation in our study area that we uses the NASA power data. Furthermore, next, we also managed to test the power data products for historical flood event replications, and we found that the power data offer valuable climate information for location without gauges. Next. Next. Eh, Hello.
I can hear you, so it's
Um,
not on your side.
oh, okay. Next, please. Or is it not showing? Mm. Oh, okay. It's in terms of enhancing our mission, the power product has been valuable to us because our first aim is to deliver a high quality research that aligns with the global interests. So in which energy transition has been the talk of the town now. So and as mentioned before, we have some limitations in ground measured data, especially for solar radiation parameters, as not all meteorological stations would collect solar radiation data. But in addressing energy transition in the context of solar energy sector, we really need the data, and that's where the power product comes into the picture. Next is it enhances our policy related studies. Um, oh, okay. Oh yeah. As it it enhances our policy related studies, as now we have data that are easily accessible. We can provide scientific justification for policy recommendations, specifically in supporting the energy transitions. And lastly, we can teach our undergraduates in using satellite data in their research, as the interface is very user friendly and easy to download. So next, please. So this is the list of publications if you want to refer, and thank you so much for listening.